According to an airline, flights on a certain route are on time 80% of the time. Suppose 8 flights are randomly selected and the number of on-time flights is recorded. Does a probability experiment represent a binomial experiment? So again, we need to check 4 conditions. Don't be confused. We're talking about binomial experiments. So we think binomial, we're thinking binomial bi means 2. But for binomial, we're checking 4 criteria. So again, we want to go through and check. So, do we have a fixed number of trials? So in this case, yes, we're talking about 8 trials. Are the trials independent? So whether one flight's on time or not depends on another flight. So in that case, they're not dependent on each other, so our trials are independent. The probability is the same, so we say that they're 80% of the time that they're on time. So our probability is the same for each trial, and then we have 2 outcomes. They're either on time or they're not. So in this case, yes, the experiment satisfies all of the criteria for a binomial experiment. Just kind of a little tip there. If you're working with these and those are questions in your homework and there's more parts, then chances are it's probably a binomial experiment. So moving along here. So we have find and interpret the probability that exactly 6 flights are on time. So again, keyword here, exactly 6 flights are on time. So we're looking for the probability that x is equal to 6. So we're looking at binomial PDF since we want just one particular value. So again, our parameters are n, so this is our n value, p, which is going to be converted as a percent, so convert from a percent to a decimal, so 0.8, and then x here is 0.6. So again, if you have one with the menus, you're going to have trials, so that is our n, and then it's going to say p, so that's our probability of success, and then it's going to say x value for x. So I'm going to do second bars and then go up because we can get to it easier. Binomial PDF, be very careful they're right beside of each other, and the menu are right up and down from each other. So I'm going to do 8, comma, 0.8, comma, 6, and enter there. So our probability there is 0.2936. So we have in 100 trials, we expect about 29 of those to result in exactly 6 flights being on time. So be careful there. B and A look similar there. So just pay close attention there when you're answering these. So C, we want to find the probability that at least, so at least we're talking about greater than or equal to. So again, remember that with the binomial CDF, we need to convert everything to less than or equal to. So we need to use the complement. So using lots of complements here. So 1 minus the probability that x is less than 6, or that's the same thing as saying 1 minus the probability that x is less than or equal to 5. So we have this is 1 minus binomial CDF, since we're calculating multiple values, n, which is 8, p, which is 0.8, 80%, and then our 5 there. And again, I can type all that in at one time. So 1 minus second bars, go up to get to a little bit quicker, and binomial CDF. And 8, comma, 0.8, comma, 5. So we're looking at 0.7969. So we would say that in 100 trials of the experiment, we expect about 80 of those to result in at least 6 flights being on time. So next, find and interpret the probability that fewer than 6 flights are on time. So the probability that x is less than 6. So again, we need to convert everything to a less than or equal to statement. So this is the probability that x is less than or equal to 5 there. So we're looking at binomial CDF n, which is 8, p, which is 0.8, and x, which is 5 in this case. So we're going to go to binomial CDF and n, p, and x. So 0.2031. So in 100 trials of the experiment, we expect about 20 to result in fewer than 6 flights being on time. So we want to find and interpret the probability that between 4 and 6 flights, inclusive, so that means we're including those values on time. So we're looking for the probability that x is between 4 and 6. So a little bit tricky here. So if we think about this, we can use CDF twice. So if I use CDF with 6, that's going to calculate all these values all the way up to 6. Right? So I can do is go and subtract something out so that I'm only left with the numbers 4, 5, and 6, or the probabilities that represent those rather. So I would need to subtract out binomial CDF up to 3, right? So this would go back in, and that would subtract out those, right? So I'll do that here. So let's do that. So distribution, which is always the top one, and then minus the bottom number minus 1 from that. And then binomial CDF, 8, comma, 0.8, comma, 6, minus, let's subtract another binomial CDF, or we can add 4, 5, and 6 together. And that gets a little bit tedious there if you were looking at several of those. If we're looking between 1 and 8 inclusive, that would take a little bit more to do that. So if we're looking at like 100 flights or something like that, that may be a little bit more difficult. So we're looking at 0.4863. So in this case, we say in 100 trials, we expect 49 of them to result in between 4 and 6 flights being on time there.